Good morning, good afternoon. Welcome to all, and thank you for joining us today in this webinar. Today, we are pleased to present to you a webinar titled Accelerating Sustainable Shipping with Rotor Sails, which is jointly organized by RENA and Norsepower. We are grateful to ferry operator Scandline for their willingness to share some operational experience with us during this session. My name is Jan-Paul de Wilde. I am Head of Decarbonization, Energy Transition and Innovation at RENA in Singapore, and I will be moderating today's webinar. It is widely acknowledged that global warming may soon result in irreversible climate change, and immediate action is required to reduce greenhouse gas emissions from across all sectors. While international shipping was not part of the 2015 Paris Agreement, the International Maritime Organization has in 2018 set ambitious targets to also reduce the emissions of greenhouse gases from ships. This is the third webinar that RENA is organizing on the topic of maritime decarbonization, and today we will be focusing on rotor sails, one of the available energy efficiency technologies. This webinar will take about 1 hour, and we will start with the presentations by each of the three speakers, followed by a Q&A session. Now, first, some housekeeping matters before we get started. Your microphone will be muted throughout the webinar, but if you have any questions, you can type these into the question box in the GoToWebinar control panel on the right-hand side of your screen. I will try to bring up as many questions as possible from the audience during the Q&A session right after the presentations. Questions which we, due to time constraints, are not able to address during the webinar will be replied personally via email. Now, without further ado, let me introduce the speakers for today's session. Mr. Giuseppe Zagaria is a naval architect and joined RENA in 2005 in the Genoa headquarters in Italy, followed by a deployment in Asia starting in 2006. In 2020, Giuseppe was appointed Director of the Asia Passenger Ship Excellence Center while still based in China. Within this role, he was fully dedicated to innovation projects across the maritime sector. Since August 2021, he is Technical Director for the Marine Italy region, supporting RENA's partners in innovation and new technologies. Thomas Risky. Thomas is the CEO of Norsepower, the Finnish manufacturer of rotor sails. He is a serial entrepreneur who has had a successful career as partner and vice president at Innofactor PLC, the largest Finnish IT service provider focusing on Microsoft technology. Thomas was actively involved in developing the business from just 5 people to a publicly listed company with now more than 200 employees. Norsepower is well respected for its rotor sail solution, a proven fuel-saving technology, while supporting the decarbonization of the shipping industry. To date, Norsepower's rotor sails have been installed on board 5 different vessels.
Good morning.
Rasmus Nielsen, naval architect, has been with the Danish ferry operator Scandline since 2003. Rasmus is responsible for the rotor sail projects on the 2 hybrid Scandline ferries operating between Rostock in Germany and Getsted in Denmark. With that, I would now like to hand over the floor to Giuseppe of RENA for the first presentation.
Thank you, Jan-Paul, and thank you to all our guests. I will proceed with my part of the presentation, starting from the real key milestone that bring all of us here, talking about emission reduction and the sustainable shipping. April 2018, IMO start the GHG, the greenhouse gas strategy, that is pushing all of us towards the 2050 through 3 layers of measure: short, mid, and long term. In briefly, this is the strategy of IMO that will, as I said, will move us towards the 2030, asking all the shipping sector to reduce the CO2 intensity by 40%, and in 2050, reducing the CO2 intensity by 70%, and the whole GHG group of gases by 50%. There is not only IMO that is pushing all of us for a sustainable shipping, but as we know, also the European Union last year approved the EU climate law that is basically open the door to a new set of directives. Most important is the so-called 54-55. In the same way as IMO, also the EU set a strategy, set a mission towards 2030 and 2050 in order to have the European bloc, let's say, completely carbon neutral by 2050. Okay, coming more on what really affect the shipping. IMO set their strategy step by step, as we know, first with the new buildings, with EEDI, but as we know, from the 1st of January 2023, also the global operating fleet will be asked to be complied and to align their emission CO2 level with what IMO is asking. So for the global operating fleet, we have two important set of requirements. The first one is a technical measure that is a sort of picture. So we will see how is the value of the EEXI based on the technical characteristic of the ship. But starting also from the 1st of January 2023, we will also start to count the real emission set by vessel that at the end of each year will produce the yearly value of the CII. Okay, without bothering too much, this is a very well-known formulation on the basis of the EEXI and the EEDI, basically represent the emission of CO2 versus the transport work. And it is in this formula that we find the way to take into account, let's say, innovative solution that aiming to reduce the general power balance on board and as a consequence, the CO2 emissions. On the operative side, the CII established five level of ranking. And of course, it is extremely important, especially for the shipping service, to plan their, let's say, retrofit investment in order to make sure that they are at least at rank C from now towards the 2026, or if we see from the collective data point of view, to 2027. Anyway, we don't expect that IMO is going to relax on this one. So we believe that the reduction rate imposed year by year will be at least kept even later than 2026. It is extremely, we are extremely glad to be here today, and we thank first Norsepower and then also Scandilines to share their experience with us. The cooperation that we established with the Norsepower team was to grant them an approval in principle certificates. The approval in principle that all the IX society are working on it, especially for us, we do believe in it. It is a sort of framework that is used to certify that some solutions are able to provide, let's say, tangible results when they are installed on vessels. Particularly for the rotor sail solution proposed by Norsepower, we carry out a design assessment and a risk assessment with a quite successful results that allow us to validate this solution as a really, let's say, a real way that can provide tangible results to reduce the energy consumption and the carbon emission on board. This was the last slide of my presentation. I thank again all of you and Norsepower and Scandilines. Thank you.
Thank you, Giuseppe, and good morning to everybody also on behalf of me. So this is Tuomas Riski, CEO of Norsepower. So I will now run a brief introduction to Norsepower Rotor Sails. And on this first slide, you see a Scandlines ferry fitted with our 30-meter rotor sail, and Mr. Rasmus Nielsen from Scandlines will later today, after my presentation, share some insights and experiences of this particular installation. But as said, I will start with a brief introduction to our core technology. So about the rotor sail, the physics of our mechanical sail are based on the ball game physics. So it's the Magnus Effect which is behind this technology. A good example of the Magnus Effect is the corner kick of the football. Without applying spin in the ball when it's kicked, it would be impossible to kick it to the goal from the corner point. So it's the pressure difference caused to the ball with the spin when the ball is flying through the air, which is making the Magnus Effect. And actually Rasmus Nielsen will also show you a demonstration of how the Magnus Effect works. But with our rotor sail, actually our mechanical sail, it's just a large vertical cylinder, and we have electric motor inside this vertical cylinder. We spend a small amount of electricity to rotate our cylinder around. And when we place it on the deck of the ship with the robust foundation, and when we trim the sail, it generates pressure difference when it's facing the ocean wind. And we can trim the sail so that this pressure difference is creating a thrust component which is pointing as much towards the bow of the ship as possible, so that it's starting to push the ship forward, reducing the propeller load and the main engine consumption and power and the total fuel consumption and emissions of the ship. So this is how it works in principle. And today in Norsepower's product portfolio, we have 5 different sizes of rotor sails. Our smallest device, it's 18 meters tall and 3 meters in diameter, and our largest device, it's 35 meters tall and 5 meters in diameter. And on board the Scandlines ferry, we have fitted one of our largest 30-meter rotor sail. And as you can see on this slide, it's kind of plug and play device. So all the devices required to rotate and operate our rotor sail are located inside of this ready-made machine. When we rotate the rotor sail, it's only the surface which is rotating. We make this rotating surface part out of composite materials. Inside the device, we have a steel support tower. So in a way, also inside this mechanical sail, we have a mast made out of steel through which we are pushing the ship forward. And all the bearings, electric motors, converters, other components are located inside the machine. And one of our newest options is this tiltable foundation, which is seen on this slide. So we can fit our rotor sails with the foundation, which has a hinge, which can be operated hydraulically. This means that when the ship is reaching the port, we can on temporary basis lower down the rotor sail to enable bridge passings and for example, loading and offloading operations of bulk carriers. So this is how our product works. Then let's have a look if I can change the slide. Good. So this is one of the most powerful sails in the world. On this slide, we have simply compared the thrust production capacity of different mechanical sails based on their projected area. And as you can see on the slide, when you compare this area of the sail with the force production capacity, rotor sail is #1 in the world. When we compare our rotor sail with kind of traditional square sail, we can see that we can produce more than 10 times more of force with this unit per area of a projected sail unit. So this is the most powerful sail in the world. With rather small units, we can make a big difference in the thrust performance of the ship and in the fuel consumption and emissions. And well, we have analyzed all the global ocean main routes based on our proven references for our rotor sails, and this is an illustration of the market or savings potential for rotor sails. On this slide, the bluish routes are the best ones for rotor sails, but as you can see on all global ocean routes, we have a positive net savings potential. So on all of these routes, we can reduce the fuel consumption and emissions with our technology. But of course, the best routes are those blue ones. Now it looks like we lost the slide, but I hope that we can get it back soon. So the best globally known routes for this technology, they are the Northern Atlantic crossing and the Northern Pacific crossing. But as you can see also on the Southern Oceans, we have great savings potential for rotor sails. And actually on all of these routes, you can reduce the fuel consumption and emissions with the technology. And also the kind of global average for like ships which are spot trading, this is looking like a great market. As said, today Rasmus Nielsen from Scandlines will share some experiences from their ferry with rotor sails. Here is another experience and example of a ship we have fitted with our devices. This is Sea Cargo RoRos ship sailing on the North Sea. We have retrofitted this ship with 2 pieces of 35-meter tiltable rotor sails. And when we calculate the kind of equivalent square sail area of this ship, we can see that this ship has roughly 3,000 square meters of traditional sail through our rotor sails. And it's making this one of the top 10 most powerful sailing ships ever built on this planet. So we can really see that with this technology, we are making the most impressive sailing fleet which has ever been sailing on our seas. Here's an example. In typical cases, the ship is sailing with 12-knot service speed. They have 3 megawatt main engine power. We have already proven that we can generate up to 8 megawatts of main engine equivalent thrust with our rotor sails. And what are the results? It looks like we are able to reach up to 25% average net fuel savings and emission reductions with this ship. The top speed has already increased in favorable wind condition from 12 knots into 20 knots. And this ship, she can actually sail with our rotor sails alone. And then there's one more slide to come. Energy efficiency regulation, which was introduced already by Giuseppe, is developing forward all the time. And to reduce the carbon emissions in shipping, IMO has decided on CII, EEDI, and EEXI indexes for shipping. And rotor sails, they can support compliance with all of these indexes. And the latest change for EEDI and EEXI was introduced in last year, December, by the MEPC 77. And this change has made it highly favorable to fit mechanical sails on board ships to reduce the emissions. And here is an example. This graph is comparing the previous version of this regulation with the new one. And it's actually showing what kind of main engine equivalent kilowatt gains you can expect with rotor sails when you fit them on board. And as you can see here, with our largest 35-meter unit, which has been simulated here, you can expect to reach roughly half megawatt influence on your main engine power in the EEDI and EEXI indexes. So instead of, for example, limiting your main engine power, it makes a lot of sense to fit a few pieces of rotor sails on board. You can gain even megawatts with this. Without compromising service speed, you can reach the EEDI and EEXI index values. And we are working hard at Norsepower to become the first company who has verified methods to make this happen. So this is what we are seeing. Okay, thank you for your interest for this presentation, and looking forward to chat during the panel discussion. Thank you.
Oh, yeah. Yes. My name is Rasmus Nielsen, and I'm naval architect in Scandlines, and I will tell you a little bit about the installation of our rotor sails on board our ferries, operating between Gedser and Rostock between Germany and Denmark. Scandlines is an integrated part of the infrastructure between Scandinavia and the mainland of Europe, and we are operating 2 routes today. We have one route between Rødby and Puttgarden, where we have 5 ferries in operation today, 4 of them as hybrid ferries, double-ended ferries, and the other route we have between Gedser and Rostock. We have our 2 newest ferries operating, and this is where we have installed the rotor sails. The ferries you can see here on the left side, we have the ferries that is operating on Rødby Puttgarden. This is hybrid ferries with a battery installation now, has been in operation for close to 8 to 9 years. So we have been focused on reducing the fuel consumption for many years, and this is still very high on the Agenda and Scan lines. On the right side, you can see our Gedser Rostock ferries where we installed the Rotor Sails. This is also ferries operating with batteries and together with the diesel engines, and now also with the Rotor Sail. Yeah, the Rotor Sail was installed on our biggest vessels, delivered in 2016. So this is close to 170 meters long and 1,600 lane meters. So as you see in the picture here, this is the installation on board both our ferries. In the front, you can see the installation on Copenhagen, and inside in the left corner, you can see the installation of the second vessel Berlin, which took place this Monday. Why do we install a rotor sail on board our ferries? This is, of course, that we would like to reduce the use of fuel oil, and we are looking into all possibilities in order to do that. So this is not only rotor sail and batteries. We try to following all these new possibilities in order to do that and try to make our vessels more and more efficient and reduce the fuel consumption. And we could see that one of the options that could be a good idea was rotor sail. So we have been looking into this for some years before we decided to go this way, and now finally we have succeeded in order to make the installations. Yeah, following up on Thomas's presentation, as Thomas mentioned, it is the Magnus Effect which gives the force to the rotor sail, so it pushed forward with the force from the rotor sail is pushing the vessel in forward direction, and we can reduce the propeller load. Now I will show a video of the effect where this guy drops a basketball first without spinning and later with spinning, and then you can see the difference, and you can see the Magnus Effect on the basketball. So now he will start to drop the ball just directly without spinning, and you will see it will just go directly down, and nothing surprisingly with this. So now it's dropped, and you can see it's just going down. There is no spin in the ball and no Magnus Effect, so it's just going straight down almost. Now, then he will do the same. He gives a little bit spin, not so much, but just a little spin, as you see here. And here you can see the Magnus Effect working on the ball, and you can see the ball is just flying away from the concrete wall. So this is how the Magnus Effect is working, and this is working not only on the basketball, so as Thomas said, on all rotating objects, this effect will happen. So it's in the golf ball, football, and also the rotor sail that we have installed on board our ferries. I will see if I can continue. Yes, now we're at the right slide. Yeah, of course, the installation of the rotor sail does not only depend on a good rotor sail and a good installation, it's also very much depending on the wind condition that we have in the area. And we have looked into that for our route. Our route is going almost north and south, and you can say the most dominating wind in our area is coming from the westerly direction, as you can see on the diagram here on the left. And as the rotor sail is similar to a sailing boat, is most efficient is the wind is coming from the side. So we actually have very good condition for the rotor sail installation on board our ferries, since we are going north and south, and we are also in a windy area of the world. So you can say the condition for us to install the rotor sail on our ferries was good. And on the right side here, you can see this is the polar diagram showing the thrust that we can obtain in different wind speed and direction. So on the paper here, it seems to be a good decision to install a rotor sail. The installation has been done in Rostock, the first one on 25th of May in 2020, and the second one we did the 16th of May, this Monday, also in Rostock. So the installation itself actually went very well. We have made a preparation of the foundation at the latest yard state before the installation of the rotor sail, so everything was prepared. And actually within a few hours after the vessel has arrived to the pier where we have to make the installation, the rotor sail was installed on top of the vessel and was made fast. So the installation in both cases went very well, so there was no issue there. It was well planned and worked very well. Oops, I think it's jumped out of my presentation now. Thank you. After the installation, of course, we have had some issues that we have looked into. The first thing we actually saw after the installation is that we had some vibration of the rotor sail with very high RPMs. So in the beginning, we was not able to reach the full revolution as we had expected. We also have seen that the stiffness of the foundation is extremely important, and the stiffness of the foundation was not sufficient. So we have to look into some possibilities to make it more stiff, and due to resonance was the reason for not obtaining the right revolutions. So some damping measures has been implemented, and this has actually solved this issue. So today we are able to operate on full speed with the rotor sail, and is operating as planned in the beginning. We have also realized that the information from the wind center is extremely important. If you don't have the right wind and speed and direction, then it's not possible to operate the rotor sail in the most efficient way. And actually what we could see that there is actually a huge influence of the wind far away from the vessel. So we actually installed the wind sensor on top of the mast and the forward mast in order to get it in a free wind as possible. We have also analyzed, or Norsepower has analyzed the wind data and made a correction to the wind sensor that we have today, so it's working as efficient as possible. We have actually also experienced that we had top on ice of the rotor sail even during the operation of the rotor sail. And of course, we have to take care of that since we have the passengers on the open deck. So we have to make sure that no ice is falling down in the head of our passengers. So we have installed ice sensors in order to detect this well in advance. So now we have a procedure in order to do so. So there is no risk for our passengers to have ice falling down. I will mention this is extremely rare that we have this weather condition that the ice will happen on top of the rotor sail. I think the last year we saw it 2 times, and this year this winter we have not seen this condition at all. We have also had some noise in the accommodation in the beginning. So since it's the passenger vessels and we have the passengers just staying below the rotor sail. This is of course an issue for us. So there has been made some additional modification of the rotor sail in order to reduce the noise, and this has actually succeeded also. So we are happy with the noise level from the rotor sail now, and this is below the requirements for the vessel. So the issues we have had in the beginning is solved now, and this is also why we decided to continue with the second rotor sail on the sister vessel. The daily operation of the rotor sail is actually working very well. It's fully automatically, so the attention from the crew is very limited. It starts up automatically based on the GPS position before both ports. We are not using the rotor sails in the ports because then the force from the rotor sail is much too high in windy condition, and we will not be able to control the vessel and do not have sufficient thrust on our thrusters to steer the vessel. We have not seen any big influence on the maneuverability of the vessel, so there's this limited effect on maneuvering in port when the rotor sail is in idle mode. Of course, one thing was very important for us also to follow up on is the efficiency of the rotor sail, because one thing is what Norsepower has calculated in the beginning of expected savings, but it's also good to have this confirmed. So actually we decided to take out the vessel for some speed test, because in daily operation it's very difficult to exactly say what is the savings from the rotor sail due to the fact that we have many other factors that have influence on the fuel consumption. So we took the vessel out, and together with SSPA from Sweden, we had made some speed tests forth and back with the rotor sail in operation and without, and we measured with the double runs the energy consumption at the different speeds and different angles to the wind. So this test actually confirmed that the theoretical calculation of the rotor sail actually fits also with the reality. So the only issue now is of course we are still depending on the wind, how it's blowing, but we are not in control of that. So we are happy with the installation. So it's working as planned. I think this was my last slide. Thank you.
Thank you, Giuseppe, Thomas, and Rasmus for sharing this information. I now invite the three of you to turn back on your cameras and yourself for the Q&A session. Just as a reminder to the audience, do type in your questions into the box in the GoToWebinar control panel, which can be found on the right-hand side of your screen. Let me kick off the questions. The first one: if rotor sails are retrofitted on existing vessels, like in the case of the Scantline vessels, what can be done in terms of engineering, preparation, and planning to minimize the disruption of the vessel's operations? And likewise, is there anything to be taken into account if rotor sails are installed on new build vessels? Maybe Thomas can kick that off.
Thank you. I'm happy to take this one. In all cases, when a rotor sail is fitted on board, it's very important to start early the planning. Then you can make it properly and make sure that any impact on the operations is minimized, and also the budget can be minimized through early planning. In a retrofit case, if there is an order early enough, we can actually, aside of any ordinary docking period, starting from even 1 week docking, we can do the entire retrofitting, meaning foundations, cabling, and also fitting of the actual rotor sail. But we have seen several cases where there hasn't been enough time to manufacture the actual rotor sail before the docking. So in these kind of cases, like with Scanlines, we have done it so that aside of docking, we have done all the preparations, installation of foundation and cabling and automation, and later on, during a suitable port call, we have done the fitting of the actual rotor sail. I can also see that it's of course important for the customer to get a good deal from the shipyard for this kind of fitting work. And also if you start planning early for your retrofit so that shipyard even haven't been selected yet, it's a good chance to prevent kind of shipyard lock-in phenomena which could increase the pricing of the retrofit. So also for budget reasons, I would recommend starting early. In a new build case, it's the same thing. If we start early enough, we can really prepare and optimize the ship for rotor sail installation. You can even optimize the main engine and propeller for variable load with rotor sails. And it's the same thing. Earlier you start, the better you can prepare. And in optimum case, we can do the entire fitting on the new build shipyard when the ship is fitted. Thank you.
Thank you, Thomas. I guess that the rotor sails are ideally placed as high as practically possible on the vessels to benefit from higher wind speeds and perhaps unobstructed wind flow. Maybe Thomas or Giuseppe can address the concerns with regards to the vessel's stability due to the weight and the high center of gravity of the rotors. Is in those cases, for typical installations, a new inclination test or an update of the trim and stability booklet required?
Of course, all the cases are different. I think maybe Rasmus can comment on Scandline's behalf how it went for them, but for us, I think the only case where we have done some inclination testing was the sea cargo installation, which I presented in my presentation earlier today. But there we have very impressive rotor sail installation. As you can see in the sea cargo case, the maximum main engine equivalent power output from the rotor sails is 8 megawatts, where the main engine is like 3 megawatts. So if you have an impressive installation, you might require some stability booklet update or inclination testing, but that's quite rare. In typical kind of auxiliary wind propulsion cases, that's not needed. But maybe Rasmus, you could comment how it went for Scandlines.
Yeah, I think it's a little bit different with the requirements with respect to cargo vessel and passenger vessels. So actually our vertical center of gravity was exceeding the maximum allowed center of gravity that is allowed to do for such installation. So we have made an inclining test after the installation. We did not do it the same day. So we have a preliminary calculation of the stability, and then we got a 2 months period in order to do so. So we took the vessel out in a weekend, Saturday night, I think 1 month later, and then we did the inclining experiment and have the stability booklet updated. But I say it very much depends on the size of the rotor sail, depending on the size of the vessel. So if it's a huge rotor sail on a small vessel, then it's most likely that you are forced to do it. And if it's a big vessel and you do the rotor sail on this one, it's probably not needed to do an inclining test.
Giuseppe, do you have anything to add from a regulatory point of view?
Thank you. Well, I would like to say something, I mean, for existing ship installation and basically just to validate the opinion from Thomas. It's really a case-by-case approach. Each vessel has its own history. And most of all, each vessel has its own operation profile and the position of VCG on which basis the stability has been approved. So I would not say we have a general rule to be applicable, but if it's a new building, it is very straightforward. If it's an existing vessel, so I mean, you need to analyze the existing stability condition of the vessel. Also because sometimes it may happen that after the installation of the rotor sail, you may have some operation profile adjustment. So I would not say the inclining experiment it's quite always required for an existing vessel. Same as, I mean, Thomas said, but can be as the experience with the Scandline, you may need an execution of an inclining experiment also because it is owner, I mean, voluntary opinion to have everything clean with a new stability booklet. That's it from my side. Thank you.
Thank you, Giuseppe. I see questions coming in about price of the rotor sails, but maybe we can put that in the context of payback time of the rotor sail installations. maybe I think Thomas is probably the most appropriate person to answer this. Could you perhaps sketch the factors that typically determine the payback time of the rotor sail installation? And I guess in that respect, also accurately predicting the wind speeds and direction of the wind on the anticipated routes play a crucial role here. It was already mentioned in Rasmus's presentation that there are predictions made. And what kind of tools are available at your site to make such predictions?
Thank you. Happy to take that one. So several important factors are influencing the business case and the actual yearly savings and emissions reductions, and of course those make the payback period in the end. Most important factors influencing that are, for example, the time at sea of the ship. The more hours the ship is actually sailing throughout every year, the better business case she will have. Then, as you mentioned already, the route and the wind conditions are varying across the planet, as I also illustrated in my presentation, and the actual wind conditions of the operational area or route, they have the influence on the business case and payback. Then it's of course the fuel type you are using through the fuel price and SFOC, which have their influence on the payback period. But to get a good understanding on the actual business case, we at Norsepower, we always make case studies through our proven references for any ships which are planned to be fitted with rotor sails. And we are already proven to be pretty reliable with our forecasting and simulation tools. And about the payback periods and investment cost in general, it depends heavily on the ship. Smallest ships we can fit with rotor sails with the €500,000 budget, and for the most impressive installations, it can already be several million euros per today. But as said, those installations are then already very impressive. Before the Ukrainian crisis and soaring of oil prices, we typically saw payback periods maybe between 3 and 10 years. Today we start to see paybacks in the best cases with like 2 years, and also the longest paybacks have been coming down because of the fuel prices soaring. So this is how I see the market today. And these paybacks, they have only been calculated based on the fuel savings and fuel prices. I also see that quite soon carbon emissions will have a price on the market that will diminish the paybacks. I see that there's kind of compliance demand. Ships need to do something to comply with EEDI, EEXI, and CII. That's slashing the paybacks. And also I see kind of ESG requirements on the market, which have influence on the business case. I think all of these are driving the market today. Thanks.
Thank you, Thomas. A question that I should perhaps address to Giuseppe. What is typically the effect on engineering, production, and installation in case a system like rotor sails or its components have an approval in principle or a type approval from a classification society?
Thank you, Jan-Paul, for this question. You know, we are in a we're in a shipbuilding moment. It is quite full of uncertainty. Okay, it is a sort of a perfect storm. The new building price is going quite high. The regulation requirement, we know there is something, okay, but guidelines and regulation clarification are coming, I mean, quite very close to the application date. So there is a general, you know, confusion and general worries in the market. That is, you know, not giving that sort of freedom to shipping company to order, okay, for what they really need. So in this, I mean, particularly moment, considering also technology that are not mature yet, we are in a sort of chicken egg situation. So we do believe in the instruments of the approval in principle, because as a classification society, we also feel the duty to express to the industry which solution they may believe and the other that may be not ready yet to believe. So it is a framework, you know, it is a certificates that may help with the stakeholders, it may help with investors, it may help with shipyards, okay, to make feel all the other players in the shipbuilding market to feel more comfortable, okay, to apply, to install a solution. So it has a technical basis, okay, but moving towards also some market benefit for, I mean, to ease the acceptance of a new solution. Okay. That's it. Thank you.
Thank you, Giuseppe. There are questions related to the stability and navigational issues. We already more or less touched upon the stability issues and the weight and the central gravity. A question from the audience is whether any navigational issues have been encountered during the ship trials or the operations. Maybe I can address that to Erasmus.
Yeah, you can say that after navigation, after top light, we have to remove from the current position and move it in front of the rotor sail, because when we install the rotor sail in the middle of the vessel, it's not possible to see the aft top light due to the rotor sails. So we got permission from the Danish authorities to install the top light in front of the rotor sail on a new mast. So this is what we have done on board our vessels. But this is of course important to look into this.
Thank you.
To comment on that one, in quite many cases we have seen that some small navigational light changes might have been required, but it seems like to become a market standard that the flag states and classes are approving those kind of small deviations to the Colrex rules. So it seems like that to me.
Thank you, Thomas. A question related to aesthetics. Let me just paraphrase this. Also, from a personal observation, I noted that the rotor sails on the passenger vessels of Scandline actually are towering quite high above the vessel. Rasmus, perhaps could you explain to us if you encountered any concerns from the passengers or any challenging issues related to safety perceptions when it comes to these installations, or is by now the rotor sails on board your vessels understood as a beneficial environmental feature?
Yeah, I think definitely the last one. I think that there has been no concern from our passengers. They think it's of course in the beginning they was looking at that and asking what is this doing? Is providing energy to the vessel, or what is it that we have installed? So we have made explanation of what the rotor sail actually do, but no concern at all. So they see it as you can say a step forward in making the shipping more green. So I think it's a lot of positive feedback we have had on the rotor sail installation.
Thank you, Rasmus. A question for Thomas related to maintenance. What kind of maintenance is typically required for rotor sails installed on board vessels? What can be done by the crew, and is there any periodic attendance of service engineers required? And in that respect, are any spare parts required or recommended to be kept on board?
Thank you. Very good question. We have a biannual standard maintenance program for our rotor sails, and the crew can do that maintenance by themselves, instructed by us. But we can also provide any type of service agreement together with our technology. Typically, the minimum service agreement which we recommend, it's including kind of remote monitoring by us, so that we monitor what's the performance and availability of the rotor sails. We send monthly reports on that one, and if there's any issue on board, then we assist remotely the crew to resolve that one. And typically our minimum service agreement, it's also including all possibly needed spare parts. And against that agreement, we actually maintain an inventory of the typically needed spare parts on board the ship, so that it's very fast and efficient by the crew to do any replacements if needed.
Thank you, Thomas. There are some questions related to the assessment of the operational profile, so the operational performance. It was briefly touched upon by Rasmus, but maybe Thomas, can you elaborate how the operational performance or the fuel savings of the vessels are typically verified?
Yes, thank you. Rasmus had a great example of sea trials being made to verify the performance. I think Scandlines was one of the first ones to make that kind of sea trial campaign. So it's a valid method, but of course you should somehow deviate the route of the ship or take her out of the traffic to do that kind of thing. Then we have done, for example, together with Napa from Finland, kind of enable-disable type comparison, so that we randomly enable or disable the rotor sail in variable environmental conditions. We collect data, and through that method we have in several cases been able to prove what's the actual fuel saving. Then with the Maersk Pelican tanker, which has been fitted with rotor sails, we did by Lloyd's Register kind of first baseline measurements for the ship without rotor sails, and then data collection with rotor sails and comparison against that baseline. It has also been proven to be a workable method. And then we have one more. We can also measure the forces acting on the foundation of the rotor sail and on the actual sail. And through that kind of force measurement, we can also do verification of the fuel saving performance. So all of these methods are applicable, and they have all been proven to work and give good results. So it depends on the ship owner's desire what kind of methods they want to use.
Thank you, Thomas. I see quite some questions coming in on the viability of rotor sails on particular routes, but if I understood you correctly, it is basically everything needs to be assessed on a case-to-case basis and for each specific ship type. Is that correct?
That's correct. That's correct. And good rule of thumb is that the further away from the equator your route is located, the better the wind conditions probably are. The most important factor when you evaluate the performance, it's the average true wind speed of the wind. That has the biggest influence on the business case. But as said, we are more than happy to do a case study for a particular route for any interested customer.
Thank you, Thomas. We touched upon the operational verification in terms of fuel savings, but there are also verifications involved in the approval of the EEDI, EEXI, and CII. You already mentioned, Thomas, that the recently updated IMO EEDI guidelines for the calculation of the effect of wind-assisted propulsion in general have actually given more benefits towards rotor sails. The calculation, I understand, is quite complex. It involves a wind matrix and other complicated mathematical formulas. But could either you or Giuseppe perhaps elaborate a bit more on the EEDI and EEXI verification process for a typical rotor sail installation?
Would you like to start with this one?
It's okay, Thomas. If you agree, I may just say a few words about this. The EEDI, EEXI, and then you may go through in detail only for the rotor sail part. So
my pleasure. Yeah.
Thank you. Okay, so the first part of the calculation, it's the same. The formulation background is basically the same as already established by IMO. So we have to identify the source on board of power. We have to fix the reference speed that we have to take into account in this calculation, and we have to consider also all the, let's say, the benefit from those systems that may reduce the CO2 emission. As we know, the contribute of the wind-assisted solution was always mentioned by IMO, even if in the first version of the guideline. But recently, I believe 4 or 5 months ago, it was a new version has been issued, and we are kind of glad, because it was reissued only to take into account a more rational and a more organized, let's say, formulation to take into account the wind assisted. So it means that at the IMO level, at the regulatory level, the wind assisted solution are now, let's say, fully confirmed as a solution to reduce the CO2 emission. Please, Thomas, thank you.
Okay, thanks. So I think nobody has ever done verification of EEXI or EEDI for mechanical sails with the current regulation, but we are preparing that at Norsepower, and I expect that within a few months from today we will have the first company with ability to do that, so that we can really get class approval for the EEDI and EEXI with rotor sails. There are two phases in this work. So first we draft that force matrix for the rotor sails in various wind conditions, and in the case of Norsepower, that force matrix it's based on our full scale measurements, but of course we have to apply those to the particular ship which has been planned through some CFD studies or so on. As said, we are preparing that one, and I want to highlight that in the case of EEDI and EEXI, that index value, it's not depending on the actual route where the ship is sailing. It's the global average wind conditions which are used to obtain that value. So road doesn't play any role in this one. So this is what is done already before the installation, kind of calculation and approval of the main engine kind of reduction average power by the rotor sails. And then after the actual commissioning installation of the rotor sails, it will be checked by the class that the rotor sails can actually perform as expected, meaning that they can reach the targeted RPM, that for example the electricity consumption is as expected in the calculation. So this is how I see today that two-phase process based on the latest guidelines. And as said, it looks like we will be the first company in the world to be fully verified to perform this work.
Thank you, Thomas. You mentioned power consumption. If I read it correctly on my screen, there is also a question on how much power consumption is required to rotate the rotor sails.
It depends totally on the size of the rotor sail. I think for our smallest units, the average power consumption is in the range of maybe 20 kilowatts. And for the larger units, it can be approaching that 100 kilowatts. It also depends on the wind condition. The more favorable route you have, the more often you are likely to rotate the rotor sails. But what is interesting, we have evaluated in different cases what's kind of the ratio of electricity consumption to the actual output on main engine level. And in typical cases, it's about 1 to 14. 1/4, so meaning that if you invest 1 unit of electricity to rotate the rotor sail, you gain 14 units on main engine level. And if you compare, if you spend that 1 unit of electricity to rotate the propeller, you gain maybe 0.6 units. So it's not a huge influence on that electricity consumption.
All right, maybe a last question from the audience, and I hope I interpret this question correctly. It is related again to stability. In case of stability checks, do we consider the most unfavorable situation, that is the maximum thrust with front wind, forward wind? In stability checks, do you consider the most unfavorable situation, that is maximum thrust with front wind?
I don't know. I can answer. I can try to answer, Jean-Paul. Okay, for you and maybe Thomas, any other comments? Okay. So the IMO intact stability code, okay, of course they provide some general guideline, okay, because we cannot issue anytime we have a new operation profile, you know, IMO cannot issue a new regulation. So we have a general requirements that I mean the ship operator, they should declare which one is the worst scenario for stability point of view. Of course, in case the presence of the rotor sail, they express a transverse they express a force that, as we know, is in forward direction, but still the vessel is rolling. We may not, because these rotor sail are not made by steel, as far as I know, are made in composite material. So we may not expect to have such a huge consequence on the stability, but case by case, the ships will be analyzed. Always take into account that we have to analyze the operation profile. That's what I can say from IMO point of view. Please, Thomas, if you want to add something.
I agree on this one. I think it's some kind of combination of worst case scenarios and average scenarios which is used there. But I want to highlight that for like air drag stability wise case, the worst case for the ship is when the wind is coming from the beam, because then the beam of the ship is making the kind of heel because of that force. And in that case, rotor sails are pushing forward. And when the ship is facing the wind, if the rotor sails are rotated fast, they are actually heeling the ship, but the air drag is not doing the same. So these worst cases, they do not occur at the same time, and I think that also has an influence on the case. But as Giuseppe said, the classes are the experts in this one.
I think from our vessels, I think it's less than 2 degrees in you can say in high wind condition that we have a heel of our vessel. So it's not a huge effect on the vessel, and we do also have a limitation on 25 meters per second. So if it's more windy than 25, then the rotor sail will go into idle.
All right, thank you, gentlemen. We have reached the 1 hour mark, and thereby the end of this webinar. To the audience, we hope that the presentations and the Q&A sessions were insightful. Please feel free to reach out to us if you have any further questions on rotor sails or the associated regulatory or classification matters. Now, on behalf of Rina and Norsepower, I thank everyone attending this webinar, and we appreciate that you have taken the time to join us today. After this webinar, we will send a link to all the attendees so that you can watch the recorded version of this webinar at your convenience, or even share it with your colleagues or others. On a final note, there will be a short survey after this webinar, and we would really appreciate if you can spare a few minutes of your time to fill it up. Once again, thank you to the presenters. Thank you to the audience for joining us today, and we hope to see you next time. Until then, please stay safe and stay healthy. Goodbye.
Thank you. Thanks everybody. Have a good day. Thank you.